slides, but
usually have like
you have to substitute every single variable. So here we actually can't get a goal out of this because we have two variables here, but we're not substituting both of them.
Oh, so we have to substitute both.
Okay, so every variable has to be substituted.
Yeah.
You can create like a new JSON object and then just sort of also edit the what is it? Like you can also do like an add recharge station. You don't have to do an add recharge station,
So
in order to sort of
problem because there's two variables.
Yeah. Yeah.
So only in all the cases of NA then. So it'd be like if you're going from a constant to a variable, and then if you have two variables and only one like substitution for that variable.
Yeah.
I think the issue is finding a position. I guess you can randomize the position if you do it that way, but
yeah. It doesn't matter where the recharge station needs to be. I guess.
Is it guaranteed to be on the path where the drone can actually reach it? Because there are some places where the drone
the
can
exact type of the substitution may be different on the quiz. Yeah,
It should be
I
able
would
to
say,
be able
just
to
broadly speaking, I haven't looked at the exams at all. Like
It should be able to
only
be
seen
like to the
practice
recharge
exams the
station.
same as you.
It doesn't have to take the path
No,
to get there.
we don't see the exams until
And
after
then
you guys
it
see
can,
them, like,
and then it'll go back on its path
If
to
you
get
ask
to the
an ETA, I don't think, like, I can't guarantee.
to its destination. So if it's like at 20%, it needs to go to recharge
From
station.
the
It'll
first
just be
two
on there.
exams and the practice exams, I
It
think
won't take the path.
Sebastian tries to have it be pretty similar.
Yeah.
The practice and the actual exam, so.
Also, like for the path strategies, they adhere to the paths directly, but like the beeline strategy, it just goes anywhere.
Could probably be like
So I guess like I'm trying to think of like examples. Let's say you take a trip and it uses like 80% of your battery.
Yeah.
On its next trip, it requires like 50% battery. So it needs to go to a recharge station first. It'll beeline to the recharge station, and then it'll continue on its path. So it'll be like it'll go to the recharge station, and then it'll continue its path from the recharge station. So if you did like A star, it'll do A star from the recharge station to the destination. Does that make sense? Or I mean, I guess that's one way of doing it.
Yeah.
You can have it be something else. It's why it's like a your design decision. So it can be up to you how you want to do it.
No, I'm just asking generally because you're able to highlight like the paths where the drones are able to move.
Mm-hmm.
Like when you tell it to beeline, does it not strictly follow those paths that are outlined on
No, so beeline will like it'll just go through the building.
Yeah, I see.
Which is fine in terms of this project because like
Yeah, so
it needs
lecture 30,
batteries,
slide
so
13.
its utmost importance is to
One thing
get
it
there
says
no
is
matter what.
strategy for solving every
So
variable
using
pattern
beeline
needs
is
to be
fine.
replaced. So I'd assume if he's saying that on the review lecture, then that's going to be the case on the exam.
So I
And
guess
then
I just have to wait.
He
for
says
my
some
partner
possible
to pick it up
variations
and then
on the actual exam. So
probably
like,
just mess around
obviously,
with
he's not
the-
going to give you this exact table on the exam, but
Yeah.
the making of it.
Again, you have like a lot of liberty with what you can do. So
yep, you might have slightly
as long
different types.
as you're keeping
like
the
you might not
you're
exactly
keeping
have
it
variable
non-trivial, it
constant
should
math.
be fine.
And then
It's up to
yeah,
you.
it all says this on slide 13.
Does that answer your
Yeah,
question?
so-
Okay.
Okay.
Sort of. There is like information in the what is it, the scheduled delivery thing?
Yeah.
Where it has coordinates. I don't know if
Okay.
those
Yeah.
are
Did you
like
do the third one again?
The third one.
Schedule delivery and
Yep.
like when you
So
I'll
in
show
the
you.
third one, we have a
in the
goal
like
and we have a substitution.
window,
A
I
substitution,
guess,
okay.
where you
So we're trying
schedule
to work
delivery.
completely backwards.
Once you've scheduled it, there are these
Basically,
weird position coordinates. I don't know if they're
Broadly
actual like
speaking, what we
positions
want to
you can
do
go
is
to.
go from the pattern to the goal.
That's kind of why
so
I
the
was
pattern is the
wanted
input,
to
the
ask,
goal is the
because then
output.
it's more convenient, I guess, to
substitution
use
is sort of
those,
a
but they
second
don't
input into the
correspond
rule
to anything. Like these,
that we can apply
are
on
they
the pattern
actual
to
like
get to the goal.
locations that
Right.
you could code to,
So-
or are they just numbers? I don't know.
When we have this goal, which is application
those
of
are like
this
the
constant
2D
foo on this
representation of
variable
like a
x,
3D.
and we
I
have the
think it's like
substitution that we know
Literally,
y.
like, this is like
we know variable
391 by
x can be
263
substituted
or,
for y.
I think that's
Right?
what it is. I don't think it has any, because like you said, I don't think it has any relation to the actual
Because that's what the
position, like in
substitution is
3D,
on.
right?
The second
Oh, so it's only
argument,
about this map specifically.
basically, if we
I
see
think
this
so.
first
I'm not
argument
entirely sure though.
Oh,
in
that's
a
not very
variable,
useful.
we can
then.
replace it with the second argument.
Yeah.
That's what the substitution is talking
I don't
about. So for
think
example,
you
here,
should have to worry about this.
if we look at number 2, say we didn't know this at first, right?
I don't.
Say we just had con.
Actually, no.
foo
I think that this
and
is an XY
the
representation.
Mm-hmm.
We know
But,
from
like,
the
in the,
substitution that
In here,
con-
you get the
variable
X, Y,
x,
Z representation.
because
I think.
x is the first
Yeah, because what
element
we
of this
care about is
bubble.
X to Y, right? We
Can
care
be
about like
replaced
XY
by
to XY.
constant
We just care about.
constant
We
of
don't really
foo.
care about the height.
So here,
of
if
the
we had
package.
this, we can look at this
The
and
height's
say,
gonna stay
okay,
the
since
same,
we
I
have
guess.
constant of foo,
I guess.
we know that that could be replaced by
It's just always
variable
just gonna be like
x.
on the
So
ground.
then
So
that's
we
what
only need to
said.
worry about
And
like
here it's
where
the same idea.
the drone
Where
is gonna
instead
start
we have
and where it's gonna end.
y equals variable of x, or
So
variable y equals variable of
yeah,
x.
I think it's just an
So
XY
here-
representation.
To just work backwards, we
Oh
start
wait,
with
so
this and we go
the
to
Z
this.
position doesn't actually ever change?
If that
Like
kind of
whenever
makes sense.
they do the package stuff?
Can we expect that?
So if you go up here, we look at this and then look at
It's gonna
the.
be the same on the test cycle.
Because I've seen it only stay
First one
at
is gonna get
this
replaced by the
specific
second
Z
one,
position,
so
so
it's not-
Yeah,
only
that,
concern
that's
is
the
with X
same
and the Y.
because
Okay.
Yeah.
that's how it's done in
Mm.
the project as well. It's a
Right.
key value
So like
pair,
it's
right?
not concerned about this, right?
And-
Because the package is not ever moving.
Yeah,
like,
generally
up to
speaking,
down. It's only
um,
moving in the. I
like
guess
if you think about a
X, Y, Z,
dictionary,
it's only
for
moving
example,
like this. It's not moving
the,
up or
the
down.
Yeah, not like a
value
helicopter,
is
I guess.
associated
Yes.
with a key.
Helicopter, everything is.
But not
random
necessarily
from
vice
what we
versa.
coded
Like you
up.
can't have one key and two different values.
I guess that does
Right.
simplify
But you
logic.
can have
like-
multiple values.
Yeah.
Or you can have the same value.
So
point
really
to
the only
multiple
thing I gotta
values.
mess with would be
So,
the X and the
It's kind of the
Y,
same thing
which
here,
are
where
at the
like you
ends.
could also have like a
Yeah.
Z variable x.
Because
But
like you said, it's
couldn't
not.
have, like,
This
Y
middle value is
variable
not really
X
gonna
and Y
change.
variable Z, for example.
Yeah.
So drone flying through stuff, we've established that's fine if it's doing beeline.
Yeah, if it's beelining to the recharge station, it's fine if it beelines. You just have to explain why. And you're right up, I guess. You're
Alright, does anybody have any more questions?
Because
about
the
this
battery
one?
is low, it needs to emphasize getting to the recharge
the last
station no
one.
matter what. So it's going
Yeah,
to
so the
beeline to
last
the.
one, we have a rule
recharge station.
that anytime we see a variable, in order to get to a goal, we have to substitute that variable, right?
Okay.
So,
I think that's all the
because
questions
we
I
have two
so-
variables here, we have
Okay.
f and x, but we only have one rule. We only have f.
It's gonna be so
that
annoying though
is-
to have to
F can be
put a
turned into
bunch of
constant
them
foo.
places.
We don't have any
Yeah.
rule about the variable x.
I think it'll be the hardest to
And
get just
therefore
one
our
working, but
substitution
then
is incomplete,
look, it'll just be like copy
is what we're
pasting
saying.
code after that.
There's two variables?
Yeah, because there's two variables, but only one rule. Because in our substitution, we don't say anything about what happens to x, right? Even though we have a
If
variable
you did,
x in the
I
input.
guess, edit functions
because of that, we
in
can't
other
get a goal out of
classes
this,
that
because we don't
weren't
know
just
what
the
variable x
battery
becomes.
and whatever else you created,
What if it
is
was
that
like
fine?
constant,
Just to like
in the
make your
pattern?
functionality work.
Yeah, if it was constant, then
That's okay.
that would be fine.
Okay.
Then we could substitute constant f for constant foo,
Okay.
because, yeah. Alright, is that good with everybody?
Yeah.
Okay. Yep.
So you can go from a constant to a variable, but you can't go from a variable to a constant.
You can, yeah.
Other way around. You can go from a variable to a constant. Yep, so like what we do here, you can go from a variable to a constant, but,
But the variable can't replace the constant.
yeah.
Okay.
So if those constants brought into
Alright, I'm gonna erase this if everybody's okay with that. So it looks like there is a small typo on the mock midterm.
That's what I'm looking at. It's like 2 parentheses, is that what you're talking about? Or is it supposed to be like a tuple bar? Or?
It should be 2 parentheses. I'm just writing it like as
Okay, tuple.
yeah, but well, no, I mean, technically it should be a tuple because if you look at the type, it says like application of expression star expression.
Yeah.
That you're not gonna get dot points for.
Right.
I would imagine, but yeah, I think the typo is in this part here. Just after the equal sign, I think it should just say constant x and not application of constant x. Because as you can see, application needs 2 inputs. But I imagine that's just a typo because I think that's fixed on the lecture slides.
Well, it's fixed, it's either on like the thing itself or the lecture slides, I forget where.
Just it should be.
I think he said there was 4 things wrong.
Yeah.
Application requires 2.
Yeah,
I don't remember what he said.
I'll point them out if I see it.
Yeah.
Okay, so here, we're doing something pretty similar to the first problem, but slightly different, right? So in the first problem, what we were saying is we had individual variables that we could substitute for other constants or variables. But here, what we're instead doing is we have an expression, and then we're saying either that whole expression or some sub-expression is equal. Like, we have an equality, basically, of either that whole expression to another expression or some sub-expression inside it to another sub-expression. And we're saying, okay, if we take this expression and we apply this equality, we'll get some result on it. So I think it might be easier to do this by example. The first one, it's the easiest out of these 3. So can someone tell me, if we take this expression and we use this equality as a substitution of sorts. So basically we're saying we can substitute this right-hand side for this left-hand side. What are we gonna get in this first part? What was it? Yep.
Do you have to write contour or just bar?
Constant bar, because that's what the equality is. So that is this one. Learning markers.
My personal one.
Oh yeah, thank you so much. I'll make sure to give it back. And if you have to leave early, just let me know.
Okay, yes, I'll do
Oh,
that.
that's the second one, the equation. Constant.
As I was walking through there, I was like, what is it? Right on, chance I get the right
Just
something.
copy the whole thing on the first, the left side, and then distribute it instead. But you could, yeah.
Yeah, I mean that is.
That's what you said, right?
That is one way of doing it for sure. But yeah, can everybody see what we're doing in this first case? This one is pretty trivial, right? We just we have this left side. We say, okay, this whole left-hand side is equal to this whole right-hand side. So then we can just write the right-hand side. So if he gives you an expression and an equality, and the left-hand side of this equality is exactly the same as this whole left-hand side here, just write the right-hand side. And then that's problem solved. So this is kind of the simplest case. Here we have something a little more complicated where you have the input, you have the output, and you have to give some equality such that if we make a substitution in accordance with the equality, we get the output, right? So here, what I would look for is see what's changed between the input and the output. So what's changed here?
Just the const and the conf.
Yep.
So you can just equalize that.
Yep. So we can see we have the app, the outer application, exact same between the two. And we can see the second argument of the application, this var x, is the exact same between the two, right? But the only thing that's changed is this con cf has become con foo. That's the only thing that's changed between the two. So that can be our equality. If we're saying that this is equal to this, then we can just write our equality as Does everybody see what we're doing there? Any questions so far?
So if we start in the slides like before that answer, he starts off with like just by putting it that it's like you can start out by thinking that like the expression like for the equality, the expression is equal to the result. Like you can have that as a result, but then he just says like this is wordy, and so you should probably change it to that.
Yeah.
Would like the big answer of saying like literally having equality and x equals right, would that be correct or not quite correct?
That I'm not sure of. I would have to see the rubric. I would imagine in the worst case that would get you most of the points. Maybe not all of the points if there's a better answer.
I assume so.
Because you can see how like this is it's always true that if you have a left-hand side and a right-hand side and you have to have an equality that equates the two of them, you can just say this equals this.
I mean, yeah, you could give like a trivial solution, but that's probably not.
Yeah, I would say if you can't think of anything else, just write it down. But if you see something that maybe makes more, that you think maybe is more along the lines of what he's looking for, like in this case, for example, you can see that like.
Yeah.
Okay. Is that good with everyone? All right. Now this third problem, it's a little trickier. This third case. So we have an equation that says application of con CF and con X equals con X. And we have this result at the end. Application of con CF and con X equals con X, right? So one thing that might be tempting to do is you can say, okay, this is equal to the left-hand side of this. So we can just put con X here. And while that seems tempting,
I think you said you can't go backwards.
Yep. So you have to go left-hand side to right-hand side. So basically, if you're applying this equality, whatever's on the left-hand side of this equality must be in the input, and whatever's on the right-hand side must be in the output. So because like while this is the same as this, because this text is on the left-hand side of the equality, but it's not, because this text isn't on the right-hand side of the equality, we can't just directly substitute, right? But we see that the right-hand side of this equality is a con X, right? And do we have con X anywhere in our final answer?
Yeah.
Yep, we do, right? We have the second argument. So what we can do is, we can just say, okay, this is so this is the first argument, right? Just con CF. And the second argument, because we know an application is two expressions joined together, the second argument can also be an application. So we can just write
He's subbing in this equality for this equality of con X and right in here.
Yep. Yep, so we're taking this whole thing, because we see this is the same as this, right? Can everybody see that? So, because whatever's on the left-hand side of this equality has to be in the input expression, and whatever's on the right-hand side of this equality has to be in the output goal, or the output result it's called here. So, we can, if we have this whole thing as the second argument to our input expression, this equality allows us to substitute this for con X, and then we can have con X.
Why do you use the comma there? Or is that because on here, up here, they just have two parentheses for each variable. Is that just another way to write the variable?
It's a little syntactical difference. I think, I don't know, I mean, what I'm writing here is technically more correct based on the type definition, because if you scroll up to the type definition at the top of problem 1, we have here application of an expression coupled with. So that's what I've been doing here. I think it's just a minor typo. I would imagine that's not something we do points off for. But if you do get points off for that, submit a regrade request. But yeah, yep. So I guess in order to avoid that, just follow the type definition. Any type that you have to use on your exam, we should give you a definition for. So you'll know the syntax that goes into it. For example, like this application and constant and variable, that definition is given at the top of problem 1, right? So if you use it, just follow how it's how we give it to you. Okay, does anybody have any questions about this problem? Problem 2? Alright, I will erase this. I need to read problem 3 quickly. I was looking at this morning and I looked through 1 and 2, but I haven't gotten a chance to read 3 and 4 just yet. So I'll read it quickly and then I can